All right, let's dive into one of the sneakiest, most frustrating problems you'll ever find in programming, the deadlock. You know, it's like this silent bug, a ghost in the machine that can bring a whole application to a grinding halt.
You know that feeling, right? An app on your phone or computer just freezes. It doesn't crash, there's no error message, it just sits there, completely ignoring you. What's really going on behind the curtain? A lot of the time, it's not a bug in the traditional sense, but a kind of digital standoff.
And that standoff has a name: deadlock. The best way to picture it is to imagine two cars on a super narrow, one-way street meeting head-on. Neither one can move forward because the other's in the way, and neither is going to back up. That's a deadlock. In the software world, it's when two processes, or threads, are each holding onto something the other one needs, so they just end up waiting for each other. Well, forever.
Now, a gridlock like this doesn't just happen by chance. It actually requires a very specific set of circumstances. I like to think of it as a recipe. You need 4 very specific ingredients, all at the same time, to cook up a deadlock.
So, what are these 4 magic ingredients? First up, mutual exclusion. This just means a resource, like a file or a database connection, can only be used by one thread at a time. Think of a single-person elevator. Only one person gets to use it. Second, you have hold and wait. This is where a thread is already holding on to at least one resource while it's trying to get another one. Third is no preemption. This one's important. It means you can't just snatch a resource away from another thread. A thread has to release what it's holding voluntarily. And finally, the real kicker, circular wait. This is the linchpin. It's where thread A is waiting for something held by thread B, but thread B is waiting for something held by, you guessed it, thread A. It's a perfect, unbreakable circle of waiting.
Okay, theory is one thing, but let's actually see how this plays out in the wild. We're going to walk through a classic example and watch these 4 conditions come together to create a total system freeze.
Okay, let's set the stage. We've got 2 workers, let's call them thread 1 and thread 2, and we've got 2 tools they both need to do their jobs, resource 1 and resource 2. Now, here's the crucial detail, the order they need them in. Thread 1 needs resource 1 first, then resource 2. But thread 2 grabs resource 2 first, then wants resource 1. I think you can probably see where this is going.
All right, here we go. Thread 1 kicks off its task. It successfully grabs and locks resource 1. At this point, everything is A-OK, running just as you'd expect.
Almost at the exact same time, thread 2 starts up and locks resource 2. So now, both threads have the first tool they need. The system is still running smoothly, no hint of trouble, yet. And here's where our problem starts. Thread 1, still holding on tight to resource 1, now says, okay, I need resource 2 to finish my job, but it can't get it because thread 2 already has it. So what does thread 1 do? It just stops and waits. It's now in that hold and wait state we were just talking about. Now for the other shoe to drop. Thread 2, which is holding resource 2, now tries to get its second tool, resource 1. But who's got that one? That's right, thread 1 does. So now thread 2 is also forced to stop and wait. See the circle?
And there you have it. That's the final moment. Thread 1 is waiting for thread 2, and thread 2 is waiting for thread 1. Neither can move forward, and neither is ever going to let go of what it's holding. They are, quite literally, blocked forever. That, my friends, is a deadlock.
Okay, so we've seen just how easy it is to fall into this trap. So the real question for any developer is, how do we stop it? How do we break that cycle before it even has a chance to form?
Thankfully, we have some really smart strategies to tear up that deadlock recipe. The most direct way is just to get rid of the circular wait condition altogether. You can do this by creating a lock hierarchy, basically a strict rule that says you must always lock resources in this specific order, like always grabbing resource 1 before resource 2. If everyone follows the same order, a circle can never form. Another cool trick is using a try lock. Instead of waiting forever, a thread tries to get a lock, and if it can't, it just backs off and tries again later. No more stubborn waiting. And finally, you can just set timeouts. A thread will only wait for a certain amount of time, and if it doesn't get the resource, it gives up. That stops it from getting stuck in an infinite loop of waiting.
So, let's zoom out for a second. Why is it so important for a developer to really get this stuff? What's the big picture here?
Here's the bottom line. Understanding deadlocks is what separates writing code that just works sometimes from engineering software that works all the time.
It's all about building apps that don't just fall over under pressure. You want them to stay fast, reliable, and responsive no matter what's going on.
So I'll leave you with this thought. Now that you know the 4-ingredient recipe for a deadlock, mutual exclusion, hold and wait, no preemption, and that all-important circular wait, where do you think one might be hiding in plain sight? Think about your online banking app, a big multiplayer video game, or even the operating system running on your computer right now. That silent standoff might be happening a lot closer than you think.